Hey everyone, so the way we left the last video was that the spans were still being sent to the console. We'd enrich the spans with some span events, some span attributes, the span status, but they're still going to the console. So time is short, let's get you into the code, and then I'll circle back and I'll explain exactly all these terms and what's going on in the code. Okay, so let's build the system from the back. We need a place to send the spans. So I'm going to use the CNCF project called Jaeger, and I'm going to start the all-in-one image as a Docker container and expose two ports, 16686 and 4317. 16686 is the user interface, the UI port for the browser, so I can see something, and 4317 is the standard port that OpenTelemetry uses to receive traces in at the GRPC endpoint. So here is the Jaeger UI, and you'll notice there's already one service called Jaeger All-in-One. Jaeger traces itself, so let's ignore that. Most backends will allow you to send spans directly to them, but I don't recommend you do that. I do recommend that you put an OpenTelemetry collector in the middle between the span producing entity or entities and the backend. Remember, a span producing entity could be something as small as a pod, and you could have thousands of pods, and a collector offers a lot more functionality than just being a routing device. So let's start the collector up. Let's test this out, and to do that I'm going to use a utility called tracepusher. Tracepusher is a very simple way to generate a single span. Here, as you can see, I'm going to send it to localhost on 6006. It's an insecure endpoint. The service name is service A, span 1, and it has a duration of 2000 milliseconds or 2 seconds. So executing tracepusher, I get, as hoped, a response code of 200 OK, and that response code is coming from the collector. So if I jump into the collector logs, you can see indeed the span did get to the collector. Question is, did it get into Jaeger? Refreshing Jaeger, we can see we now have two services. One of them is called service A, and if I click find traces, there we are, I get my span 1. So that proves the wiring works. We can get a span from A to B via the collector, everything's good. So let's jump into the actual code and see what's different from last time. So the first thing you're going to need are some other dependencies. Make sure your requirements file looks like this, and you do pip install -r requirements.txt again before following the rest of this video. Okay, 99% of this code is exactly the same as the previous video. The differences start on line 15 and 16, where we're defining two different new variables: collector endpoint 127001, of course my local machine, and the collector GRPC port 6004. Remember, that's the port of the middle box, if you will, the collector that's running in the middle. Then line 18 we've commented out. Remember that console span exporter says export the spans to the console. Instead, we're exporting the spans in OTLP format. But we're going to send the spans to an endpoint on 127.001:6004. So that is how our application knows where to send or emit the spans that we produce. Let's run our application, keep our fingers crossed, and yeah, this should all work. Okay, the result is 14, exactly the same result as before, but notice we don't have anything printed to the console this time. Hopefully, flicking into Jaeger, go back and refresh the page, we now have three services, one of which is Adam's MacBook Air. Remember, that was the resource name from the code that we set. Hitting find trace, I'll see a span called add, and it had a response time of 2 seconds. Fantastic. And that's it. That is how you get a span from your code via a collector into a backend of your choice. But there's a little bit more going on in this span. So let's jump back to the code and have a look at what's actually going on further down. I've actually mocked up or faked a feature flag system. Now, feature flags are great, and I'm not going to get into them in this video, but suffice to say, they're a way of controlling code from outside of the code itself at runtime. A feature flag system has three things that you really need to know as an operator of these distributed applications. The first is which tool. That's the provider name. Then you obviously have a key of a feature flag and the value of what the flag actually is. And that's what we're setting here. We're saying the feature flag key is feature enabled, and the flag value is just hard coded in this demo to true. So let's have a look at this code. We're saying if the feature flag key is feature enabled, well, we know that is the case because it's hard coded to be that. And the flag value is true. Well, again, line 34, it is true. We are going to sleep for 2 seconds and then process the rest of the code. What would happen if I set this to false and reran the code? Well, you can actually see there, it has already, responded a lot more quickly. But looking at the spans, I should see 2 spans now, one of which is 2 seconds, one of which is 22 microseconds. Now, of course, as an operator, that's going to confuse you because you're thinking, this the same thing happening. Why is it different? Why is it drastically different timing? So having a look at the 2 seconds and drilling into the span or the trace, we can see the span attributes. My fake feature flag backend is feature enabled and it's true. Okay, so that combination of things leads to it being 2 seconds. Let's have a look at the quick one. My fake feature flag backend is feature enabled. The variant is different. The value is false. So now I can start to understand as an operator why the system is behaving differently because of these span attributes. Notice as well that I didn't define these span attribute keys, these names. Span attributes comes from OpenTelemetry themselves. What I can do is import span attributes and then ask what is available. And you can see here there's a whole huge list of standardized things like the client address, the client port, the cloud event, the function as a service invoke name, and so on and so forth. So these are standardized events. So across your company, you can use the same words and the same language to describe the same thing. So there we are. That's how you get spans from a producing entity, i.e. this code, through an OpenTelemetry collector into a backend of your choice. So let's now dig in at the deeper level and see what was really going on with all of that wiring and all of that configuration. The first thing we need to know is what language or what protocol or what format can we send that data out. Now, unsurprisingly, there are a lot of different formats. The standard one being the OpenTelemetry protocol. So a little bit like if I speak English and you speak French, we need to speak the same language. So where I'm sending the data needs to be able to speak OTLP. That's pretty much the standard these days, and every endpoint pretty much can do that. And certainly if I was evaluating a tool or a vendor, I would be asking, are you OTLP enabled? Are you compliant to OTLP? Can you accept those traces? The next thing we're going to need to know is HTTP and GRPC. So let's dig into it and see what we can come up with. So at the moment we have our laptop. And we have our Python program, and the Python program is printing some stuff to the console. Now, what we actually need though are those spans to go out to some sort of useful backend. And basically you send your spans to the collector, and then the spans, and then the collector is configured to talk to the backend. So you're putting an extra component in there, but you get a lot of benefits with the collector, which I'm going to go through in a different video. But in short, you can think of a collector like a pipeline. It takes things in, it can process them, it can do things with the data as it's flowing through the collector, and it then outputs it, as in this diagram, to the backend. Now that we've got that and we've decided on a collector, let's talk about HTTP and gRPC. So we have our laptop or our Python code, which let's call it our client. And we have a recipient or a server or a backend. Now HTTP, as you probably are aware, is a single request and response. So you make a single call and you get a single response. And then a few seconds later, you need to send some more spans. So you send another call, you get another response, and so on and so forth. So there's a lot of overhead with HTTP. gRPC, think of it conceptually more as setting up a tunnel. So you set up a connection that is persistent, and then the data just kind of flows in a stream like water. So for that reason, I prefer gRPC where I can. Now, by convention, you will see two ports used with OpenTelemetry: 4317 and 4318. Now, there is absolutely no reason that you can't pick other ports, of course, but in the documentation and by sort of convention, 4317 is gRPC and 4318 is HTTP. So if you ever see those two port numbers and you're trying to guess what people are using, then 4317 is gRPC and 4318 is HTTP. I am going to pick, for the purpose of this video, I'm going to pick gRPC, but I'm not going to use 4317. So you'll probably notice that the wording was a bit weird there. I actually recorded that last bit first, so it was referring to the video that was coming, and obviously you just watched that, so apologies. I'm a little bit too lazy to re-record it, but I hope you found that useful. We've now got the spans getting sent to something that looks nice and is actually useful to process this data. In the next video, I'm going to take it a step further. Remember those maths problems that you had as a kid where you would take a number, times it by 7, do some other maths to it, and basically come out with someone's birth date? We will code that in Python and we will trace the whole thing. The reason is so we can show OpenTelemetry span header propagation, so that we can generate a complex trace that in reality may span multiple virtual machines, different data centers, and so on. Join me again there, where we're going to really start fleshing out this example to be something beyond just the basics, and of course we're going to visualize it in Jaeger. So I hope you've enjoyed. I'll see you next time. Bye.